This video is about simplifying radical expressions. So we have simplifying radicals, and we're actually going to be simplifying radical expressions. So I'm going to extend this and say expressions. The difference between just radicals and radical expressions is that just simplifying radicals have only numbers in it, but since we're going to be dealing with numbers and letters, we want to have simplifying radical expressions. Now we will look at simplifying radicals themselves. I'm going to show you how to simplify radicals using your calculator to get the exact answer instead of a decimal. But most of what we're going to be doing on here will have decimals in our answers. The main thing that you need to be able to do is to simplify the variables, because decimals, you can always check the decimals in your calculator. So the first thing we're doing is label the following parts of a radical expression, because when I say these words, I'm going to use the vocabulary to explain everything, and you have to be able to know which part I'm talking about. So the first part, the 7, is actually called the coefficient. Coefficient. Coefficient is a number multiplied to an expression. That 7 is multiplied to the square root of 3. So the 7 is your coefficient. The 2, which you won't actually always see, but that's considered a square root. So the 2 is what we call our index. Our index. Now you cannot have an index smaller than 2. So the index has to be greater than or equal to 2. You cannot have an index smaller than 2 because there's no such thing as a 1th root. There's a square root, cube root, 4th root, and anything above. So if you don't see a number in there, like if you look down here, there's no number in the index, that means that it is a 2. If it's anything bigger than 2, it has to be written there. And the last part of our radical expression is called the radicand. The radicand. This 3, the stuff underneath the radical, is called your radicand. So if you remember back to the quadratic formula, the discriminant was what was underneath the radical in the quadratic formula. The discriminant would be considered your radicand. Radicand. The radicand is what's underneath the radical. So we have a coefficient, the index, and then the radicand. I'm going to show you how to simplify these radicals using our calculator, but decimals are not acceptable. So on here we have the square root of 28. Instead of trying to actually simplify it by hand, we're going to look at our calculator. So the square root of 28. The first thing we want to do is actually get a value as to where is the square root of 28 close to. So we do the square root of 28, and we see what the whole number is. The whole number is 5. So the reason we do that is because we're going to use our table to help us. So we're going to go to y equals, and we're actually going to type in the radicand, 28, divided by, and then x raised to the power of the index. The index, since there's no number there, is at 2, so it's going to be raised to the x squared. Now again, the reason why we did the square root of 28, we got that whole number of 5, is we're going to go to our second window, so a table set. We're going to start it at 5. And then we're going to do second table and look at our graph. Now what we're going to do is move up, and we're going to find the first time when we have 2 whole numbers. So 5 isn't right, 4 is not correct, 3 is not correct, 2 has a 2 and a whole number. So what that means is that this is actually going to be our answer. We write our answer out as the 2 is our coefficient. We still have the square root symbol because our index is still a 2. But then our 7 is our radicand. So if we get out of here, so second mode, so quit, I have the square root of 28 gave me this decimal. I'm going to type in 2 square root 7, 2 square root of 7, and I should get the exact same decimal. And I do. Because this, yes, these are the decimal values. This is a simplified version of it, and that way I can have without decimals. So if you ever see a problem that says to simplify this, you can use your calculator. So I'm going to do the same thing with example B. So again, I'm going to show you these 4 examples in the calculator. So the first thing we do is we take the square root of 80, and get that whole number to know where we need to start with. So we're going to start at 8. So go to our y equals, and we do our radicand, 80, divided by x raised to the index. The index is 2 because it's not there, so it's raised to the x squared. Okay, so it's divided by x squared. And again, we had the value of 8. So we're going to go to our second window. We're going to start it at 8. We'll go to our table, second table. Now again, we're going to go up until we find our first. Both of them have to be whole numbers. Go up, nope, 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 yes. And please understand that you cannot have it after in the negatives, okay? So the first one that we saw, again, it was starting at 8. First one we saw was 4 and 5. So that means our 4 is our coefficient. 4. We still have the square root symbol, so that's really a 2. And then our radicand was the 5. And again, we can do 4. We still have the square root of 80 in there. We can do 4, then the square root 5. Press enter, gives us the exact same decimal. This next one, we're going to do the same thing, so I'm going to find out where we start at. So square root of 243, and I have 15. That's the value we're going to start with. So I'm going to go to my y equals and type in the radicand. 243 divided by, it's x, and then it's raised to the index. The index, you don't see it, is squared, so it'll be raised to the x. It'll be divided by x squared. And then again, we figure out where it starts at. So again, 15. So we go to second window, and we want to start it at 15. And then we go look at our table. Second table. First time we see a whole number. So nope, no, 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 yes. So we have 9 and 3. That's our first whole number and whole number. So even if there's more, there could potentially be more than that. See, we have 3 and 27. We don't want that one. We want the very first one we came to, which was that 9 and 3. So 9 is your coefficient. We have the square root of, and then 3 was your radicand. Then went 9 and then 3. So the last one is the square root of 504. So again, we go to square root of 504 to know where we're starting at. We're going to start our table at 22. We go to y equals. We type in our radicand of 504 divided by x raised to the power of. Our index is 2 because you don't see a number. So it's raised to the second power. And then again, I'm going to press second mode. Remember, my number was 22. So I'm going to go to second window. I'm going to start it at 22. I'm going to go to my table. I'm going to move up. So no, not yet. See if anything happens. So even though this is a nice decimal, we still don't use it. We have to have whole numbers. So even though 3.5 is nice, we don't want it. Keep going. So first time we have it is 6 and 14. So our coefficient is 6. Then we still have the square root because that was our index. And then our radicand was the 14. This is actually how you simplify radicals without giving decimal values. You just plug them into your y equals and find the coefficient and then your radicand. These next examples are perfect square examples, so you can actually just type the numbers into your calculator and it'll give you a nice decimal, or a nice value. So a is the square root of 16. It is equal to 4, not the square root of 4. This gives you your exact answer. So this is just equal to 4. You stop there. You don't go any further with that because it gave you your answer in your calculator. And you know that 4 times 4 gives you 16. That's why the square root of 16 is 4. Be careful about that. The common mistake is that people would put the square root of 4 and then it goes down to 2 and then they have square root of 2 and just gets it all messed up. Example B, again, you can put the number in your calculator but not the letter. That's one of the things we're going to be working on. The square root of 25 is 5. The square root of y squared, anytime you have an even exponent, the square root of y squared is just y. And we're going to be working on the variables. We're going to be working with the expressions that are not perfect squares. Example C, the square root of 49 is 7. The square root of w to the 6 is actually w cubed. because it's w cubed times w cubed is w to the 6th. If we go back to exponent rules, this will be w cubed times w cubed. So then that'd be 3 plus 3 is 6. And then z to the second, square root of z to the second is just z. These are perfect squares. And anytime you have an exponent with an even number, that's an automatic perfect square. And basically you just divide it by 2. Now these next ones, it says you try. Simplify the following. Mostly written in simplified radical form and decimal form to the nearest hundredth. And actually, I'm just going to put them in decimal form so that we can see the decimal values. Now, you can still use your calculator to determine the simplified radical form, okay? But I do just want to put them into decimal format right now. So I'm just going to type in the square root of 750. And it's 27 and 39 hundredths. That's 6 makes that 8 go to a 9. So 27 and 39 hundredths. So it's approximately 27 and 39 hundredths. And again, you can still go to your y equals and do 750 divided by, 750 divided by x squared because your index is 2. And then we know it's a 27, so you would go to start your table at 27. And then you would go to your table, and then you would find the whole numbers, and that would give you your simplified radical version. So it would end up being, it would be 5, and then the square root of 30, because that would be your coefficient, and that would be your radicand. So it would be 5 square root of 30. For example B, again, I'm just going to get the decimal value, so it's the square root of 162, and it's 12 and 73 hundredths. So approximately 12 and 73 hundredths. Part C, the square root of 24 is 4, and now this 8 makes the 9 go to a 10, which then makes this 8 go to a 9. So this is really 9, 0, so 89 goes up to a 90, so it's 4 and 90 hundredths, or 4 and 9 tenths, so approximately 4 and 9 tenths. Now you don't change that to a fraction because this should be a decimal. So those are getting the values in your calculator for decimal values. Those are just radicals. Now we have radicals and variables examples, so this is radical expressions. It says do not simplify the number. That means that we just want a decimal. Okay, so we want the decimal value for that. Okay. Later, we don't actually have to do that right now. Okay. We're only going to simplify the variable because I just want to focus on specifically just the variables to make sure you understand how to do that. On these last 3 examples, we're going to be combining these 2 things together. We're going to get the decimal value, and then we're going to simplify the letters. Okay, so we're focusing specifically on these right here. These 2 problems is specifically focusing on the variables. So to simplify these, what we do is actually take our variables, we're going to separate them. This is x to the 4th, so x's. What we technically do is we're actually going to divide our exponents. Now these are exponents and they're going to stay exponents. Exponents stay exponents. So we're going to take our 4 and we're going to divide it by our index. Our index is 2, so we actually have 2 goes into 4. Now the square root of x to the 4th, that's a perfect square already, so I want to show you how that comes to play. So the 2 goes into 4 2 times with the remainder of 0. This is just long division, basic long division. What that means is that this is going to be an x squared, because this is an x. This becomes the exponent on the outside of on part of the coefficient. This tells you that we have a radical, so the little r kind of looks like a small little radical. And this tells you the exponent of the variable on the inside of the radical, which doesn't have one, so it's just x squared on the outside. Therefore, I don't have a radical left on that x squared. So all the x's will be on the outside of the radical, of the coefficient. Then we're going to do our y's. So for our y's, again, we have our index, 2 goes into, and then our exponent is 7. So 2 goes into 7 3 times nicely. When we multiply, it becomes 6. So there's a remainder of 1. What that means is that this is the exponent of the coefficient, so the y raised to the third power. Then we have a radical, and this is the exponent of the radicand for our y's. So our y's, we're still going to have that square root symbol because we still have a radical because there's a number right here. That means we're going to have a y in the inside raised to the first power. So the 3 is to the coefficient and the 1 is to the radicand. Now we did not touch the 75, so what we do for our answer is we take all of our coefficients. We have our x squared and we have our y cubed. These are all of our coefficients. Then we keep our radical. So our radical is the square root of. Now we take our radicand, your number first. We did not simplify the 75, so we just put that 75 in there for now. Then we take all of the radicands from our variables. The x's had no radicand, and the y's had a y to the first in our radicand. This is our answer. This is simplified for the variables. We were not simplifying the numbers. We're going to do that down here. So we take them individually, and we're basically just dividing them. This is a quick and easy way to see that this is your coefficient exponent, and this is your radicand exponent for that letter. So be careful about what letter you're working with. So on B, example B, we're again specifically just looking at the variable, so the r, so only the r. Now the index is a 2 because you don't see a number. If you don't see the number in the index, it's a 2. So we have 2 goes into, the exponent of your r is 7, so that goes in here. Now 2 goes into 7 3 times with the remainder of 1. Because 3 times 2 is 6, and there's a remainder of 1. So again, what this tells you your exponent of the coefficient. So it's r to the third. Then we still have that square root. And then this tells you your exponent of the radicand for your r. So it's r to the first. And that's our only variable. So what we do, again, we take all of our coefficients. Which was r cubed. That's the only coefficient we have. We keep our radical. It's a square root symbol. And then we take all of our radicands. First, your number, 224, because we did not simplify that. And then your letter. So we still have a radicand of r to the first. So it's r inside. And you can put the 1 there to see your numbers, your 3 and your 1, your 3 and your 1. And then that's our final answer. Now for these last 3 problems, what we're going to do is actually we're going to combine finding the decimal value and the variables. So the variables are the part where you have to do the most work on. So if we look at this one, and I'm also changing them to different types of indexes so that I can show you how to do multiple different parts. And I will actually show you how to do in the calculator when you're dealing with a different index as well. Okay, it's actually the same thing, but you just divide by x raised to the third and x raised to the fourth. So I'll show you that in just a moment. All right, so for this first problem, we're going to get the decimal value. So the square root of 128 is approximately, so we're going to get our coefficient, square root of 128 is approximately 11 31 hundredths. So that's our coefficient right now, 11 31 hundredths. And then we're going to deal with the n. So for our letter n, our index is 2. Goes into our exponent is 8. 2 goes into 8 4 times with the remainder of 0. And that should happen because remember, anytime you have an even exponent, it's a perfect square. Since we're doing the square root, that'll give you a nice clean number. So this is actually n to the fourth in your coefficient. And then since we don't have anything left in our radicand for our letter, we don't have a radicand. So we don't have to put the radical. And that was each of the parts. So now we're just going to write our answer. Take all of your coefficients. So we have 11 31 hundredths. And then we have n to the fourth for our coefficient. And if you notice on both of these parts, we no longer have a radical left over at the end. That means that we have no radicand. So this is actually our final answer. So we have approximately 11 and 31/100ths into the fourth. On example B, we're going to do the same thing, but this time we're dealing with the cubed root of 56. It's highly important that you notice which index you're dealing with. You can still do this in your calculator to get the actual coefficient. So we have the cubed root of 56 is approximately, so we're going to go to the calculator. And if you press your math button, you can actually change it's a cube root right here. And part 5 means you can actually put any type of root you want to. So if I go to 5, notice I have something in front. I have to actually change that thing to whatever the index is. So I'll put a 3 there for the cube root. I could have also done math 4 for the cube root, but this one will help us know for any root. Okay. And then we have inside our radicand is 56. So we get 3 and 83/100ths. Now if I go back and do the cube root, do the same thing, 56, I get 3 and 83/100ths as well. So both of these do the same thing. So 3 and 83/100ths. So I'm going to write that, 3 and 83/100ths. So approximately 3 and 83/100ths. Then we're going to deal with the letters. So the first letter is X. X. The index is 3, so we do 3 goes into the exponent is 5. So 3 goes into 5 one time with the remainder of 2. So what that means is we have x raised to the first for our coefficient. Our index was still a 3. This is a 3, so it's the cubed root. And then we have x raised to the second in our radicand. Then we'll do, so that's the x's. Then we'll go to the y's. For the y's, our index is 3, goes into our exponent is 1. Well, 3 does not go into 1, so then we put a 0 with the remainder of. 0 times 3 is 0. So then 1 minus 0 is still a remainder of 1. So if 3 can't go into 1, whatever was your exponent is still going to be your inside. So this is equal to y. There was none on the outside. There's no coefficient of y. So we still have the cubed root of the y, and we have an exponent of 1 on that one. So we've gotten our number, our x, and our y. So now we're just going to put them together. So if we look at all of our coefficients, everything outside the radical, so we have 3 and 83/100ths, so approximately 3 and 83/100ths. Then we have x to the first is in our coefficient, and that's all of our coefficients. So now we have the cube root symbol. And then in our radicand, we still have an x squared, and we have a y to the first. And that's our final answer. And I will show you how to actually simplify this in the calculator in just a moment. I'll go back to it. On example C, we're going to do the same thing, but this time it's a fourth root. So the fourth root, we're going to separate the fourth root of 448 is approximately. So this time, instead of doing the cubed root, I'm going to do the fourth root. So I'm going to do math. I'm going to go down to number 5. I just have to change this number to a 4. And you can actually do that before you even press that button, but I just like to go and change it. And then I'm going to do the 448. And I get 4 and 60/100ths. So this is approximately 4 and 6/10ths, or 4 and 60/100ths. Then we have to focus on the x's. So again, so for the x's, we have the index is 4, goes into the exponent is 7. 4 goes into 7 one time with the remainder of 3. What that means is that we're going to have an x to the first as our coefficient. Our index is 4, so we still have the fourth root. And then we have an x to the third as our radicand. We go to the y's, we do the same thing with the y's. So again, the index is 4, goes into the exponent is 7. So again, 4 goes into 7 one time with the remainder of 3. That means that we have a y to the first as our coefficient. We still have that fourth root because that's our index. That's still our index. Then we still have y to the third in our radicand. So for our answer, since we've done each part of them, put all of your coefficients together. So we have 4 and 60/100ths as our coefficient. We have an x to the first as a coefficient. We have y to the first as a coefficient. And that's all of our coefficients. Then we look to see, do we have any radicands? We don't have it on the number, but we do have it on the letter. So we still put our fourth root. Then we have our radicands of x cubed and y cubed. And that would be your final answer. Now, again, I want to be able to show you how to do these values, the 3 and 83/100ths and the 4 and 60/100ths, using your calculator to actually simplify them. So if I get my calculator again, I want to put it into my calculator, y equals, and I have 56 divided by x raised to the, my index is 3, so I have to raise it to the value of 3 because that was my index. Now, because I have the decimal value, this again is still where I'm going to start my table at. So second window, I'm going to start it at 3. I'm going to look at my graph, my table. And this is actually the first time it works. So what this would become is, instead of it being a decimal, I could actually keep this as, this is my coefficient and this is my radicand. So I'm going to write it out real quick over here on just a scrap piece of paper so you can see it. The cube root of 56 is equal to, the 2 is your coefficient, we have the index of 3 still, and your radicand is 7. So if I wanted to combine all of those, so I would have 2 for the coefficient, x to the first is a coefficient, and there's no y coefficient. Then I'd have my cubed root, my 7 is my radicand, my x squared is my radicand, and my y to the first is my radicand. So this is actually the simplified version of it without decimals. You will not, I'm not expecting this to happen every time, but what I'm saying is you can get the same values by using your calculator like we did earlier. And so on part C, if I did the same thing, this time I would do 448 divided by x raised to the index is 4, so it would be to the 4th. I still have my decimal value down here, so I know my starting value is going to be 4. Second window, I change that to a 4. And then I look at my table. I find my first whole numbers. So it's 2 and then 28. So what that means is the fourth root of 448 is actually equal to, the coefficient is 2. The index is still the 4, because I keep the index, and then the radicand is the 28. So if I wanted to write part C with no decimals but have it completely simplified, all my coefficients are the 2, the x, and the y. So 2, x, and the y. I would have my index of the fourth root. My radicand starts with the number of 28, and then I'd have x cubed, y cubed. So this is actually the simplified version of part C. Now again, this is not, you don't have to be able to do this. I'm just showing you how you can do it in your calculator. You take the radicand and you divide it by x raised to the index, and then look at your table. So again, you start your table off at the whole number of the decimal that you got, and you just do second window to change your table. Second window, and you can start it anywhere you want to. But again, you want to start it at the whole number of your decimal and just move up until you find your whole numbers. Now, if you do not have whole numbers, so if I do 13, let's say 13 divided by x squared. Okay, so I'm going to do the square, technically the square root of 13. So if I look at the square root of 13, it starts at, I'm going to start it at 3. So second window, started at 3. If I see no whole numbers, I have 1 and 13, that means I just have one coefficient and 13 is your radicand, which doesn't change anything. It will just be 1 times square root of 13. It's the same thing. So sometimes your numbers won't simplify, and the only whole number you have is 1 and the radicand. So that means that you can't simplify that any further, and that's okay. But as soon as you get to 0 and it says error, you know that you can't do anything else. So that's how you simplify radical expressions. So you're going to divide, you got to know what your index is, and you're going to divide your exponents by your index. And then whatever you have your coefficient exponent and your radicand exponent. Again, these were originally exponents, and they have to stay as exponents.